Welcome to saitechinfo, dear UPSC, TNPSC, NEET and JEE aspirants and school and college students.
My dear students, in this session we'll be explaining how the hyperbolic functions are periodic. Now, sin hx is equal to e power x minus e power minus x whole divided by 2. Now, what we are going to prove is sin of hx, okay, this remains unchanged by adding, that is sin h of x plus 2n pi I. So this results the same. So that is what we are going to prove. For instance, you have got the quadrant, first quadrant, second quadrant, third quadrant, fourth quadrant. Now the circular function goes like this, starting from 0, pi by 2 and pi, 1.5 pi and 2 pi and goes on. So as a circular function, okay. So here it is going to be periodic, okay. So what we are going to prove is this sin x is equal to sin of x plus 2n, that is integral multiples, so that is 2 into n into pi of I, okay. So they remain unchanged, that is the sin of h of x is unchanged. So that's what we are going to prove. Now let us consider sin of hx. We already know that is equal to e power x minus e power minus x whole divided by 2. So what we are going to do is, instead of x, we are going to have x plus 2 into n pi of I. Okay, so 2 into n power of I means that is the n number of what? Periodic function. So x plus 2 into n plus I, e power x plus 2 into n pi I minus e power minus x minus of x plus 2 into n pi I whole divided by 2. Now we know a power m into a power n is equal to a power m plus n. So we can apply this rule, and therefore this e power x plus 2n power 2n pi I becomes e power x into e power 2n pi I, and this value is equal to 1. Therefore e power x into e power 2n pi I minus e power minus x into, in the same way, minus of plus minus and minus of plus minus. So e power minus 2n pi, and this term we already declared that this is 1, and therefore e power x into 1 minus e power x minus x into 1, and we have got this 2. So e power x minus e power minus x whole divided by 2, that is equal to sin hx, that is hyperbolic sine function. So irrespective of the theta, whether n pi 2n pi I is added or not, this remains unchanged. So sin of h of x remains unchanged, okay. So similarly we can prove for cos x also, as well as tan x, okay. Let us proceed with cos x. See, cos h of x is equal to, we know, e power x plus e power minus x whole divided by 2. So here we are going to prove that cos of x, cos h of x plus 2 pi n I is equal to cos of hx. So this remains unchanged. We are going to show that. Let us consider this equation. So cos, and we have got already this cos of h plus x plus 2 pi n I. Okay, instead of x, we are going to replace this with x plus e power x plus 2 pi ni plus e power x minus minus of e power x plus 2 pi ni, okay, whole divided by 2, right? Okay, now n may be any integer. So in this case we are going to proceed further as, right, now 1 by 2 we can bring this. So the same thing we can do, that is e power x plus 2 pi ni is nothing but e power x into 2 pi, according to a power m plus n is equal to a power m into a power n. So e power x into e power 2 pi ni, and then plus, then we have e power minus x into e power 2 pi ni, okay, close bracket, right? And we already know this is 1 and this is minus, because minus of plus, so this is also 1. Therefore e power x into 1 plus e power minus x into 1 whole divided by 2, which is nothing but e power x plus e power minus x whole divided by 2, that is nothing but cos, hyperbolic function of cos of x, okay. So similarly we can prove that, that is tan, hyperbolic tan function of x, that is tan hx is equal to tan h of n not to n pi x inside. Okay, let us prove, because this remains unchanged. Let us consider, we know already tan of hx, that is hyperbolic tan of x is given by e power x minus e power minus x divided by, that is e power x plus e power minus x. Now let us consider, instead of x we will put tan h of x plus n pi by pi I of x, okay. So here we have e power x, okay, and then plus n pi I minus e power minus x of plus n pi I whole divided by e power x plus n pi I plus e power minus of x plus n pi I, right? And now we can split this e power x into, and we know a power m plus n is equal to a power m into a power n. Similarly, e power x into e power n pi I minus e power minus x minus, e power minus n pi I plus and minus minus whole divided by e power x, then e power n pi I minus e power minus x, here plus e power minus x and into e power minus n pi I. Our objective is to eliminate this second term, okay. We already know e power 2n pi I is equal to 1. So in that case you can multiply this equation by, the numerator as well as denominator by n e power n pi I. Okay, so let us multiply and divide by e power n pi I, the entire equation, and therefore it becomes e power x into e power, you know very well, e power n pi I into e power n pi I, which is nothing but e power 2n pi I, is it not? That is a power m into a power m is equal to a power m plus n, and here 2n. So 2n pi I, and then minus e power minus x into e power minus 2n pi I whole divided by here e power x, and then e power 2n pi I minus e power minus x into e power minus 2n pi I. Okay, so we already know this term is equal to 1, right? Therefore, e power x into 1 minus e power minus x into 1 whole divided by e power x into 1 minus e power, sorry, this is plus e power 1. Okay, so this is equal to e power x minus e power minus x whole divided by e power x plus e power minus x. This is nothing but tan h of x. Okay, so it means we have the proof that tan hs is periodic. Okay, so here what is its period? Its period is n pi I. So tan h function has a period of n pi I. It has a period n pi I. Okay.
யாம் பெற்ற இன்பம் பெருக இவ்வையகம் என்பதற்கேற்ப please subscribe if you like our educational contents and share with your family and friends. Thank you for spending your valuable time.